Hello everyone. Today we are going to see a topic refraction through a prism. In this topic we will learn about prism, angle of deviation, and the relation between angle of deviation is denoted by deva and angle of prism A. So see very carefully how this things will be done here. So first of all, see in this whole program what is the prism. Prism is also same like as a glass. It is refracting medium. It is a refracting medium, just like as a glass, lens, etc. In this, the speciality of prism is it has 5 surfaces. Prism contain made up of glass, refracting medium made up of glass, and it has 5 surfaces. Out of these 5 surfaces, three rectangular surface and 2 triangular surface. So 3 rectangular and 2 triangular surface, total 5 surface made up of glass, and just like a glass it is a refracting medium. Now see how the phenomena of refraction takes place with prism. So we are going to watch first of all refraction in prism. Now see this refraction phenomena here in this diagram. Here this, see the green line. This triangular surface, this represents prism A, B, C. Here the triangular surface represents a prism. Here in this prism we are going to take one ray of light. This is incident ray. Incident ray P and Q. Prism is kept between A, B and C in this triangular surface. Triangular surface of this kept down. Another triangular surface opposite to this, and this side here, here and here 3 rectangular surfaces are there. So ray of light is allowed to fall on rectangular surface of the prism. The place where it strikes at point Q on a prism, we are going to draw a normal here. Normal, and it denotes angle of incidence I. Thereafter, here in this, after the refraction, this is air, glass, air. Air to glass bends towards a normal. Let this small r is angle of refraction, and this ray of light is called refracted rays. See this refracted ray. Again, let this is point R. Again, ray of light is passing from medium glass to air, denser to rare, bends away from the normal. See, this is one more normal at point R is required. Let this angle is R dash and it is I dash. This ray of light is called emergent ray of light. Let it is S. So PQ is incident ray, QR is a refracted ray, and RS is a emergent ray of light. This is the phenomena of refraction takes place inside the prism. Now see the phenomena of angle of deviation in this total discussion. After refraction in a prism, let us see what are these what is the angle of refraction. Here what we are going to do, this is incident ray PQ, and if prism is not available here, then it goes incident ray in this direction. So I want to proceed PQ forward here, and when one view the emergent ray from here, it seems to come in this side, so proceed RS backward. The points where this proceed rays intersect, treat as a D. Carefully, D here. This angle of this angle is called angle of deviation Deva. This is called angle of deviation Deva. Now take some points here. Let these two normal intersect at point E. Take this is point is M, and here this point is N. ME, NE, two normals are here. Now see the procedure. What is the do? We want to calculate the angle of deviation. What is angle of deviation? By this formula, angle of deviation. Angle of deviation, when you want to see, we are going to take first of all this triangle. What is this triangle? DQR. See in triangle DQR. In this, see this angle. This total is I and it is R, then it is I minus R, and this is R dash and it is I dash R dash, so it's become I dash minus r dash. And sum of two interior angle is third exterior angle. In this deva is equal to sum of two interior angle. The interior angles are I minus r plus I dash minus r dash. So it can be written as in one bracket I plus I dash minus r plus r dash. Treat this equation as equation number 1. When we proceed to make a relationship between angle of deviation, angle of incidence, and angle of prism refractive index of material of a prism, let us proceed the mathematical calculation. Now we are going to take four-sided quadrilateral, four-sided figure AQER. Right? In quadrilateral AQERA, see very carefully, we are knowing sum of the all four angles in a quadrilateral is 360 degree. In that, first of all, see, it is a normal 90 degree and this total is a 90. 90, 90, 180. This implies that angle A plus angle E is equal to 180. Because the sum of these two is 180, the total is a 360. So angle A plus angle E is equal to 180 degree. So right here as equation number 2, in quadrilateral four-sided figure A, Q, E, R, A, angle A plus angle E is equal to 180 degree. Treat this as equation number 2. For next mathematical equation, let us see very carefully. We are taking a triangle QRE. QRE, in that sum of these three angles are equal, is a 180 degree. So R plus R dash plus angle E is equal to 180 degree. So we may write for a triangle, see, for next triangle we are taking QRE. In this triangle, sum of angle R plus R dash plus angle E is equal to 180 degree. Now compare between these three equations carefully here in it. First of all, from equation 2 and 3, if right hand side is 180 degree, this implies that angle A plus angle E is equal to R plus R dash plus angle E. It is angle A plus angle E. Angle E is cancelled by angle E. So angle A is equal to R plus R dash. Treat as equation 4 it is. Now we are going to place value of R plus R dash in equation number 1. Then this equation 1 can be treated as in that angle of deviation, see in this angle equation, angle of deviation dy is equal to I plus I dash minus, in place of R dash we can write angle A. can see by this equation 5 very clearly this angle of deviation depends upon two factors here, angle of incidence and I plus I dash, angle of incidence and angle of emergence. Angle of incidence oblique emergence. Second, angle A in the diagram. This angle A is called angle of prism. So see carefully in the formula, it is angle of prism, and this angle of prism is depend on R and R dash. Here in the diagram, R and R dash. An experiment is performed for the refraction of a prism at different angle of incidence, and it is observed that the different angle of deviation is obtained. See in the diagram, as I changes, angle of deviation changes. So 5-6 experiment are done for different angle of incidence, angle of deviation measured, and a graph is plotted against angle of incidence to angle of deviation. This is called I-Deva graph. Here in this I-Deva graph, take this point as a origin, angle of incidence I, angle I-Deva graph. This is called here in this angle of deviation and angle of incidence I. It is called Deva I graph, angle of deviation. I first term on y-axis, second term on x-axis. This is the tradition. Now see very carefully, take a calibration scale, angle of incidence. This angle of incidence we are taking 10 degree, 20 degree, 30, 40, 50, 60, 70, 80 and so on. And we are going to take, this is angle of deviation 10 degree, 20, 30, 40, 50, 60, 70, 80 and so on. When various angle of incidence, the experiment is performed from beginning 30 degree and goes up to 80 degree, then this type of curve is obtained. Various points on this graph you see. See, as angle of incidence increases, angle of deviation decreases in the beginning and gets minimum value. This minimum value of this is known as minimum value of angle of deviation at a given angle of incidence. Then on further increasing the angle of incidence, this is angle of incidence and it is angle of deviation increases, shows again increases. This is the graph nature. At this stage, when experiment is done at minimum angle of deviation, we may write here, if Deva is equal to Deva minimum angle of deviation, at this it is obtained that angle of incidence equal to angle of emergence, and R is equal to R2. At Deva minimum, see in the diagram, actually this diagram is made on minimum angle of deviation. In that condition, this angle both equal, and angle of incidence I and angle of emergence is equal. And this one more important result is obtained in this experiment. This refracted ray becomes parallel to the base of prism, BC. These two becomes parallel when this angle of deviation is minimum. So at that condition, the refracted ray becomes parallel to base of prism as given in the diagram of this. This diagram is made under these circumstances. Now see, what are more things we can do in it? If we apply Snell's law. Snell's law speaks for refractive index n is equal to sin I by sin r. It can be also written as sin I dash by sin r dash. See, we are going to obtain value of I and value of r, and will keep in this Snell law formula that is represented by equation number 6 here. So I is obtained by equation 5 when Deva is equal to Deva minimum under these circumstances, because Deva is given I plus I dash minus angle of prism A. If I is equal to I dash under this condition, this implies that Deva is equal to Deva minimum is equal to 2I minus A. This implies that 2I is equal to Deva minimum angle of deviation plus angle of prism. Again, this implies that I is equal to Deva minimum angle of deviation having minimum value plus A by 2. We are taking this equation number 7, and equation 8 is given angle A is equal to R plus R dash. If R is equal to R dash under minimum condition, then A is equal to 2R, implies that R is equal to angle A by 2. Equation 8. See it is. We have two equations 7 and 8 for I and R. Then we are going to keep this value in the Snell law formula. That is refractive index n is equal to sin. What is I? In place of I, Deva minimum plus A by 2 upon sin R. R is A by 2. This is the required formula, which is represented by equation 9. It speaks that refractive index depends upon parameter 1, angle of deviation under minimum condition, A, angle of prism, these two factors, and one more we can say material of prism, but not necessary to show. Basically these two factors according to the formula. Prism is very thin prism. This thin prism, in that condition, Sine I can be treated as I, and sine R can be approximately taken as R. Then this formula, equation 9, can be written as n is equal to sine angle of deviation minimum plus A total by 2 upon A by 2. See, 2 is cancelled by 2. So it's become cross multiplication. En A is equal to angle of deviation under minimum value plus A, or by solving this equation obtained for minimum is equal to n minus 1 into A. So see the formula, angle of deviation by this formula, refractive index and angle of prism. And by this formula you may see here the equation 8. So this is the whole calculation, whole derivation is for given topic here. Refraction through a prism here in this case. So this is for the total topic. Thank you and have a nice day to all.